Engineered for dominance in mining operations, this truck was designed to carry immense payloads. Yet a single undetected fault nearly halted its reign. It stands taller than a two-story house. Its tires weigh more than a fully grown elephant. And when fully loaded, it hauls more weight than a commercial jetliner. This is the Caterpillar 797F, a $5 million dump truck that isn't just big. It's essential to the modern world. You'll find it deep in the oil sands of Canada, the copper pits of Chile, and the gold mines of Western Australia. It doesn't just move dirt, it moves billions of dollars in resources. Built to endure relentless punishment from searing heat to frozen ground, this machine hauls up to 400 short tons per trip every single day. But beneath all that steel is a hidden flaw, a design issue that nearly crippled entire fleets and put lives at risk. Today, we're unveiling the inner workings of one of the world's priciest dump trucks and revealing the flaw that nearly brought it all to a halt. This is Hard Hat Industries. Let's start with the numbers, because the Caterpillar 797F doesn't do anything small. This truck is part of the Ultra class. That's the largest haul truck category in the world, and it earns that title. It can carry 363 metric tons of material in a single run. The truck itself, it weighs just under 690 tons when empty. From bumper to bumper, it stretches nearly 50 feet long. That's longer than a standard city bus. At its tallest point, the 797F stands over 24 feet high. You don't just get into this truck. You climb into it using a ladder. Inside, it's powered by a Caterpillar C17520 engine, a 20-cylinder diesel beast that produces 4,000 horsepower. Top speed? About 40 miles per hour, which might not sound fast until you remember it's doing that while hauling 400 tons of material. Now, let's talk cost. Each 797F runs between $5 and $5.5 million depending on options, shipping, and region. And it doesn't stop there. Each tire, a Michelin 5980R63, costs upwards of $40,000. And you need 6 of them. That's $250,000 just to keep it rolling. Fuel tank? 1,000 gallons. That's about 3,785 liters. And under load, this truck burns through roughly 18 gallons per hour. You don't refuel the 797F with a pump. You refuel it with a convoy. But here's the thing. All of this power, all of this size, it's not overkill. It's barely enough to survive what comes next. Are we overbuilding these machines, or are we finally matching the scale of the world's most extreme jobs? The 797F isn't built for highways. It's built for open-pit mines. And nowhere is it worked harder than in Alberta, Canada, home to the largest oil sands operations on the planet. These sites are more like engineered landscapes than traditional mines, and the 797F is the workhorse that makes them run. You'll find fleets of these trucks operating in places like the Kearl Oil Sands Project and the Suncor Millennium Mine. Conditions here are brutal. Winter temperatures drop to negative 30 degrees Celsius. Summer hits 40 degrees Celsius. Terrain is unstable, dusty, or frozen solid. But the 797F keeps moving, hauling dense bitumen-rich sand across steep, unpaved inclines all day, every day. On a typical shift, these trucks operate up to 22 hours a day, stopping only for refueling and critical maintenance. Inside the cab, the operators work alone, isolated, high above the ground. They monitor everything: engine temp, brake systems, tire pressures, payload balancing, all while driving a $5 million machine through chaotic terrain. It's not just about hauling material, it's about trust that this machine won't fail and that every system is doing its job. Because if it doesn't, the consequences are massive. When a 797F goes down, it's not just a repair job, it's a production disaster. One truck offline can delay an entire extraction cycle, costing operations hundreds of thousands of dollars per day. That's why uptime is everything. And yet, despite the maintenance, despite the engineering, something did go wrong. And it nearly brought a whole fleet to a standstill. Are these trucks the most reliable machines in mining, or are they sitting on a razor's edge? In 2012, a critical issue emerged at a gold mine in Australia. Multiple 797Fs, all well-maintained and operated by trained crews, began showing unexpected structural issues. The problem? Not with the engine, not with the tires. It was the chassis. Specifically, stress cracks in the main frame's weld joints. Under full load, especially on uneven terrain, the frame was flexing beyond design limits. Vibrations caused microfractures to form, and when metal fatigues over time, it splits. These weren't minor cracks, these were structural failures, threatening the truck's ability to operate safely. The most serious case came from a mine in Western Australia. A fully loaded 797F navigating a rocky haul road detected a frame crack during routine inspection. It was halted just before a failure that could have stranded it mid-cycle. One missed inspection. That's the margin between a normal day and a catastrophic breakdown. Caterpillar launched a full investigation. They traced the flaw to weld imperfections in the early 797F frames. Under sustained stress, heavy loads, rough terrain, and long hours, the chassis couldn't cope. The company deployed a global retrofit operation, reinforcing frames with stronger welds and adding support plates. They inspected over 140 trucks for emergency repairs, costing operators an estimated $30 million in delays and losses. But even with the fix, the flaw had been exposed. If a truck this advanced can suffer a fault that dangerous, what else could be lurking inside these giants? Can even the best engineering truly guarantee safety at this scale? Today, the 797F remains one of the largest, most powerful mining trucks in the world. But there's a new shift happening: autonomous trucks. Caterpillar is already rolling out driverless 797F units in parts of Western Australia. These trucks use radar, GPS, and AI to operate without anyone inside. They're faster, more consistent, and statistically safer. Komatsu, Hitachi, and Liebherr are all doing the same. For operators, it's a revolution. For workers, it's a question mark. What happens to the men and women who have spent decades mastering these machines? The people who built careers on knowing what a hydraulic wobble sounds like, or how to feel slippage on loose gravel. A world of autonomous mega machines is coming, but we're not just replacing drivers. We're replacing an entire culture of industrial skill and experience. Are we witnessing the last human generation of the world's biggest machines? The next generation of ultra-class haul trucks may not roar with diesel. They might glide silently, electrically, and without anyone in the cab. While the 797F dominates today's mines, a new contender is quietly rolling into the future. Meet the Liebherr T264 Electric, one of the world's first fully electric ultra-class haul trucks designed for zero-emission mining. Developed in collaboration with Fortescue, this isn't just a retrofit. It's a transformative adaptation of the T264 platform, redefining what a haul truck can be. At its core, a 3.2 megawatt-hour battery, one of the largest ever installed in a land vehicle. That's enough energy to power an average home for about 4 months. The truck connects to a fast charging system capable of up to 6 megawatts. That means it can go from 0 to full charge in under an hour during shift changeovers or planned breaks. It's being deployed at Fortescue's Australian mines, where the challenge isn't just going electric, it's staying productive in harsh remote environments where uptime is everything. What makes it special isn't just the lack of diesel fumes, it's the precision. With advanced torque control and zero lag, electric haul trucks offer smoother acceleration, better traction, and less mechanical wear. And because there's no roaring diesel engine, the cab is nearly silent. This isn't the future. It's already happening. And it's changing what miners expect from the machines they rely on. Is this the beginning of diesel's decline in ultra-class mining? Or just a high-voltage experiment? The Caterpillar 797F is more than a machine. It's a symbol of human ambition, of what we build when the stakes are high and the terrain is unforgiving. It moves mountains. It reshapes landscapes. It fuels industries that power the modern world. Even the strongest machines have flaws, and every giant can face change. Because in heavy industry, nothing stands still for long. There's always a bigger load, a tougher job, a more extreme frontier waiting. This was Hard Hat Industries. Subscribe for more stories behind the world's most powerful machines and the people who keep them moving.